Cost estimating is one of the most important subject areas in construction or project management. And as project managers or construction managers, understanding the basic concepts and fundamentals makes you an efficient construction or project manager. So today what I'm going to do is to walk you through some basic concepts and fundamentals in construction cost estimating in North America. Now the goal here is not to make you an estimator, but to really walk you through some basic concepts that would allow you to interpret estimates and have knowledgeable conversation with your client about cost estimating. This session is very good for project or construction managers, or if you are new to estimating in America, this course will introduce you to important concepts in cost estimating. Now, let me introduce myself. My name is Seth Danquah. I do have many certifications. One of them is the Certified Cost Professionals from AAC. I have been in the industry for over 18 years and I still do cost estimating. Now, with that out of the way, please join me and let's get started. Now, before we start, I want us to take a look at the agenda for today. So we will be looking at, let me put it here. Okay, we'll be looking at the life cycle cost. And then we will take a look at the what we call capital cost. Then we will look at construction cost. And then from after that, we'll look at uncertainties in construction cost. And then I want to look at the market's effects on construction costs. And if there's time, we will look at or maybe we should also look at the cost breakdown structure. Yes, I think this is what we would be having today. I think we should have enough time to cover these topics. I want to shrink this a little bit so we do have enough space on the board. Now, so let's start. What is a life cycle cost? See, every project has a beginning and an end. If we define what a project is, we say a project is a temporary endeavor undertaken for a specific purpose. Now, because of this, every project has a beginning and an end. So if you consider the duration that a project goes through, that is let's take for example a school building. We build the school project, we hand it over to the owner. The owner operates the facility for a while, and then after its useful life, the owner decides to demolish the facility and return or restore the site to its original conditions. So for the school building, it goes through building, operation, and then demolition. So that is the life cycle of the school. Now every project has that, even though the project's lifespan could be 100 years, it still has to go through some sort of a life cycle. Now, the life cycle cost is the cost that an owner incurs throughout the life cycle of a project. Okay. And in construction, that life cycle cost could be broken down into three parts. So let me put it on the whiteboard. So that life cycle cost, I'm going to use LCC for short, is equals to the initial cost outlay, which is the initial cost to build a facility, okay? plus the cost to operate and maintain the facility. So that is operations and maintenance. And then there is, at the end of its useful life, the project gets demolished. So that is the demolition, or sometimes they call decommissioning. If it's the oil and gas industry, they decommission the facility or decommission the facility. So this is the life cycle cost. I'm trying to make it all on one line. Now the initial cost is known as the capital cost. So I'm going to change the equation slightly and have it LCC. It is equals to the capital cost plus the operations and maintenance, and then plus the demolition or decommission. Or the decommission cost. So this is what we have for the life cycle cost. Now, as project managers or construction managers, we hardly ever use the life cycle cost. Okay, most often than not, we are dealing with just the capital cost. So why do we even have to talk about life cycle cost? The only reason I brought it up, one, to just sort of education, to educate you that we do have life cycle costs. The other thing is also that life cycle becomes very, very useful when we are evaluating project alternatives. Okay, so when, let's say, an investor has two projects to look at, we always look for the most viable one or the most profitable one when we are talking about profitable projects. And in that case, we have to look at the whole cost of the project in order for us to determine that project viability. And so we use things like capital budgeting and decision making, where we have methods to be able to calculate which one is more profitable or which one has the highest rate of return. So you have things like the net present value of a project, which obviously takes into account all the life cycle costs. So, and then we also have the IRR, which is the internal rate of return. So those are areas where we use the life cycle cost. But other than that, you're not going to use the life cycle cost very much. But within the life cycle cost, I want us to focus on one thing here, which is the capital cost. Okay, so what is the capital cost? Again, like I think I said earlier on, that the capital cost is the initial capital outlay needed to construct the project. The other way I put it is this way: the capital cost is the cost incurred to bring a project to its to a useful commercial function. Okay, so all the costs that an owner would incur, whether it's when we talk about building project, then you are talking about, let me just put it here again. Then we are looking at the land. The owner must have to buy land. And then there is also the design fees. I'm getting a lot of notifications. I wish I can get that off, turn it off or something. Just a minute. Yeah, I wanted to turn out the notification. So we have the land, we have to buy the land, we have to do a design, and then there are also professional fees, that needs to be paid. And then there is construction costs. There is administration cost. The administration cost is, of course, is that wrong? The administration cost? The administration cost. Okay. And then there's also what I call the financing fee, the finance fees. Okay, and then there are also other fees like liability, like liability and insurance. So these are all the things that goes into a capital cost. There could be more, but for most projects, this is what you are going to have: the land, the design fees, the construction costs, the administration costs, the finance fees, liability, and insurance. Now, these are obviously self-explanatory, okay? But we will talk more about them if need be. Most often than not, you're not, as a project manager or a construction manager, you are also not going to look at the capital cost, because most often they might bring us in during the construction stages of the project. If you're a program manager working with an owner, then probably you might have to work with the owner on all these list of items that we have here. And so what I'm going to do is I'm going to shrink this one again and put that in and push it here. And this is all the things that goes into the capital cost of a project. So we are going to extract the construction cost from the capital cost, and that is going to be the focus of our discussions today. So I'm going to focus on the construction cost. Okay, so let's talk about the construction cost. What is the construction cost? Now, this is the way I look at it. Construction project is always built by contractors, and for a contractor, that construction cost to them is revenue, right? So if we are talking about basic business function, that revenue is always equals to cost plus profit. So if I put here revenue equals to cost plus profit, so the construction cost to a contractor is equals to the cost incurred plus the profit. Let's keep here revenue. Okay, so revenue is same equals to construction cost. Let me expand it. So yeah. Okay. So that revenue is equals to the construction cost plus the profit. Now, that construction cost can also be broken down into two main parts or two main components. So if I have your construction cost, and this is equals to the direct cost plus the indirect cost. So that is the construction cost. But wait a minute, I don't normally see construction costs coming in like direct costs and indirect costs. And I'll explain both direct and indirect costs. Now, construction is made up of series of activities, okay? And if we can associate a cost component or any cost to an activity, that cost is called a direct cost. Okay, if we can associate it to any activity or trade, Then we refer to that cost as indirect cost. And the indirect cost is mostly the supervision costs, the temporary offices that the owner has to put up to in order for them to manage or build the project for the owner. So let's take a look at the direct cost. So the direct cost of a project is made up of the cost of, this is what I call the cost of the resources to build that project. And those resources, when we talk about construction, not even only construction, even in production, you know that the resources are labor and equipment, and of course the material that goes into the production. In the construction industry is not so different. The resources that is needed to build a facility, of course, the cost of labor, or let's put a labor cost, okay, plus the equipment cost, and then the material cost, and then the subcontractors cost. Okay, so this is what the direct cost is made up of. So these direct costs, so for every activity in a project, we find out how much the labor cost is going to be, how much the equipment cost is going to cost us, how much the material is going to cost, and then how much the subcontractors are going to come in. When we add all together, we get a direct cost for an activity or a trade. The indirect cost is also made up of two, it's also made up of two components. One of them is what we call the field overhead cost, and of course the other one is the office overhead cost. Why do I keep on getting this? Okay, the office overhead cost. Sorry. The office overhead cost. So this is the indirect cost. Now let me explain the field overhead. I think I spoke briefly about it. Now, the way the construction industry works is that a contractor has an office in which they operate their normal business, okay, but when they get a project, they set up a temporary office at the project location, and that's where they do most of the construction money. They perform most of the construction activities, and those might include a temporary building that they have to put up. They have to get supervision on the project. They also have to get permits and other things that they need in order for them to manage the project. Now, those costs are what we call the field overhead cost. And those are sometimes termed as the general conditions and requirements. Now, the office cost, even though the office does not directly work in the field, what you have to understand is that the contractor has to find a way to pay for office expenses. Okay, so even though they don't support the project directly, they do support the project from their home office. If you have the accountant in the office, the accountant's time needs to be paid. Okay, the office rent for the contractor also needs to be paid. So every project contributes to the cost, the office cost for the of the contractor. I hope you understand what I'm trying to say here. Now, and this is the way it works. Normally, we will look at the annual revenue that the contractor makes. And then what they will do is that they look at the office cost versus the revenue that they make for the year. And based on the cost and the revenue, they establish a percentage of how much each project should be contribute to the office expenses. So if a contractor, let's say, makes about 100 million a year, and the office cost is say 2 million, then we are saying that the percentage for office overhead is what, 2%. That's the 2%, and so we add 2% to each project that they get. Now there are times that they find a granular way to calculate those the office overhead, but I'm not gonna go into all that. Okay. So let me let me expand this, and then we'll push this so we can get more space. Okay, let's do this. And that is what we have. So this is the construction cost. Now there's a lot of plus there's a lot of things we added here. So to make it simple, this is what I'm going to do. I'm going to list all the items that goes into the construction cost. Okay, so if I put here the construction cost, I think today is notification day for me. So if I put here construction cost, oh my God, okay. If I put here construction costs, I'm going to put here, remember the direct cost is broken into labor costs. So I'm going to have labor costs. I'm going to have equipment. I also have the material costs, the subcontractors costs. What else am I missing here? Then I do have the field office and office overhead. So the field overhead is what we normally call the general conditions. And then we also do have the office overhead, which is G&A. That's general and administrative costs. G&A costs, okay? And then I think that's it, right? We do have the labor cost, the equipment, the material, the subcontractors cost. We do have the general conditions, and then we do have the G&A cost. Now, there are other things that I haven't mentioned, so let me quickly mention them. The other thing that we include in the cost, in the construction cost, is what we call bonds and insurance. Of course, the bonds and insurance are there to protect the owner in case there is a failure on the part of the contractor. In the construction industry, the predominant ones, of course, are the performance bonds and then the payment bonds. The performance bond are there to protect the owner in case the contractor fails to complete the project as per the specification. The the payment bonds is also included in there to protect the owner against the prime contractor's failure to pay their sub contractors. So I'm going to add here the bonds and insurance. Okay, so these are what makes up the direct all the cost of the construction cost. Do we have indirect? Okay, let's add the general conditions, and then the G&A are there. So these are the components that go into the cost of a project. Now, two things that I also have to include here. Remember when I did the agenda, I think I put there uncertainties in construction costs. So there are things we add, and one of them is the general, what we call the contingencies. And then the other one is escalation. Okay. Now, contingencies are there to deal with the uncertainties in cost. The escalation is included in there to deal with the market effects. And I think I will talk more about those as we go along. So let me quickly push this one here. and and squeeze it a little bit. Okay. So again, let me just say this is the construction cost. Okay, so anybody looking at it, we see everything we do calculate when we are calculating the construction cost of a project. So now that you know what a direct cost and the indirect cost, let's quickly take a look at an example of a direct cost, and then I think I can explain these things better over there. I'm trying to squeeze this one to give me the exact fit here. Okay. Can we? I don't think I can do anything about it. So let's talk about it. So this is a typical direct cost, and I put this up there I put this up there for this class. Now in this activity, we are doing what we call structural excavation. So this could be a transit project, or this could be a roadway corridor where we do a lot of excavation. So you can see that the quantity, which means the quantity that we are excavating, is about 90,000 cubic yards. Now, now right away from here, you can see that in order to estimate the cost of a project, you need quantities, and then you need the price. Now, the way to get the quantities is through, of course, the drawings, extract the quantities from the drawings. So in order to become an estimator, I think I said earlier on that the goal here is not to make you an estimator. Okay. So because estimating, of course, required a lot more than just understanding these fundamental concepts. One is to be able to read architectural drawings or engineering drawings and be able to interpret those drawings. Okay. There's also the need to understand the market dynamics on cost. So there's a lot more to cost estimating than understanding this concept. But I believe that if you are a project manager and understand these concepts, it makes you a better construction manager or a project manager. You're able to have knowledgeable and decent conversations with an owner when you are talking about the cost of a project. In the same way, you're able to supervise your estimators, review their estimators, and give them appropriate comments on the estimates. Okay, so let me get back to the structural excavation. So here we have 90,000 cubic yard of excavation, and we are doing about 550 cubic yard a day. So that gives us about 164 days for this particular activity. Now, those 164 days, if we are doing 8 hours per day, that translates into the 1309 hours. That is, multiply whatever you have there by 8. That looks a little bit off. Let me see why here. I think we are just multiplying this by the 163.63, and I will change that. Yeah, that's so 164 times 8, that gives me 1312. So let's put it at 1312. Okay, let's round it up. Okay, so 1312. So the 1312 represent what we call the crew hours. Now, they have crew hours and man hours in estimating. The crew hours look at the hours that a crew will spend doing the work. So over here, the crew spends 164 days to do the work. And if we translate into hours, that is 1312, that is 1,312 hours for this particular activity, meaning each crew member will spend that many hours on the project. Now, when we talk about the man hours, we are talking about the total hours that the crew would spend, and in this case, that is equals to the 11,808 hours. So that is the man hours. This is the man hours, and this is the crew hours. So you take the crew hours and then you multiply by the labor rate to get your total labor cost. Okay, in the same way, you take the crew hours on the equipment, multiply by the equipment rates, and then you get your total equipment. Now over here, because it's an excavation and because this is an excavation, we don't have any material cost. Okay, but we do have a sub cost, and the subcontractor is the one disposing of the excavated material, and that is what we have as 1.2. And so if you look at all the cost, the total cost is the 3.176. So this is the total cost. Okay, this is the what we call the unit rate. The unit rate is if you multiply the volume by the unit rate, you should get the total cost. Or in other words, if you want to get the unit rate, it's just the total that we have here divided by the volume of excavation that we are doing. So that is the unit rate for this particular activity. Now, I said before that construction is a series of activities. So you're not just going to have this one as a complete estimate. You're going to have sometimes about 200 different activities, and so your estimate could be made up of so many line items for the direct cost. Now, the other thing I want to point out here, which is also very important, is the productivity. I always say that the construction cost is dependent on a contractor's methodology, because that methodology or the methods and processes that they have in place obviously determines their productivity. And productivity plays a very important role, a very significant role in determining the cost of a project. If a contractor can do more in a day, then the cost of that project goes down significantly. Okay, so for instance, here I'm only doing 550 a day, and you can see that the cost is 3.176. If I change this productivity to, let's say, 850 a day, if I change this to 850 a day, is it working? I think I messed up here a little bit. Yeah, because I use this. Sorry guys, because I use oh, I think I made a mistake, and I think when I was when I revised the number, I think I had coded it in there, and I think that messed everything up here. So let's do this. Okay, so if I change the productivity to 850, you could see that the number changes to 2.48. If I change it back to 550, it goes back to the 3.1. So productivity plays a very important role in your estimating. Now, so as project manager, it's always good to pay attention to a contractor's productivity. A contractor should not be allowed to just change their productivity midway through the construction project. When they do that, they increase the cost of the project. Okay. So the other thing that I want to focus here is the labor rate. Here you could see that we have the labor hours times the labor rate that gives us the equipment. So let's talk about these here, the equipment rate and the labor rate. The the labor rate in construction is based off on in California, it's based off on what we call the prevailing wages. If a project is a state work or a state project, then the contractor is supposed to use the prevailing wage in that particular state. If it's a union job project, then the rate is supposed to be based off on the union rates. And if it's a federal job, then we are looking at Davis-Bacon rate. Now, this rate might be Davis-Bacon, union wage, prevailing wage. The difference might not be that big. The other option for a contractor, it's not really an option. Okay, let's say it's an option, is to go on the open market and shop if the project is none of the three I earlier mentioned. So if it's not for the state, it's not for the federal government, or it's not a union job, then the contractor can, of course, shop the labor hours on the market. But here also there are requirements. You are not required to pay below the minimum age. Now these things are put in place to protect the tradesmen or the laborers who work on these projects. Okay. So let's take a look at what is made up of. How do we get these labor rates or these rates? For the labor rate, let's go back to the whiteboard. For the labor rate, this is made up of what we call the basic wage plus the fringe benefits, and then we add payroll taxes. Is it right? Okay, then let me shrink it. So this is the labor. This is how we get the labor rate. The basic wage is how much you actually pay the contractor. The fringe benefits include things like the welfare. They are not so much different from the benefits, what do we call it, employees enjoy for working for companies. Okay, if they are working on a project, they need to enjoy these benefits, including vacation and holidays, of course, pension, and then welfare. And these are mandated by states if you are using the prevailing wage. Okay, those are the fringe benefits. The payroll taxes are the taxes you pay for, of course, employing the tradesman in doing the work. I think I do have an example of the breakdown here. Let me see what I can find it. Okay, I think I do have one here. So this is a typical labor rate calculation that I have. This is coming from the what we call it, from California, and this is the Department of Industrial Relations in California. Always every year comes up with the labor rates. Actually, in every year they come up with two rates. So they change the rates twice every year. And so this is the one that starts August 20 to June 2021. This might have changed because we are in 2022. So here you can see that the base wage is 50, and then you have to pay vacation and holidays, health and welfare, pension, training, other payments, and the total fringe benefits come up to $31.11. When you add the wage and the fringe, you get $81.60, and this is for a carpenter. And then you have to now think about taxes and burden that you have to deal with. And here we are talking about the federal insurance contribution, that is FICA. There is state disability insurance, there is state unemployment tax, and then there is federal unemployment. Now, you have to understand that some of these have limits. Okay, some of these have limits. I think that for the first 7,000, you can calculate the state. Is it the state unemployment tax? The state unemployment tax on these. Okay, so by the time you finish, we are looking about 86.64 for the wage, fringe, and taxes. Now, I also added the workers' compensation. Now, if you are hiring workers on a project and they get hurt, they have to be taken care of, and that is where we have the workers' comp. So now, if you're on a project where the owner is taking care of that in a project where we have what we call OSIP, which is the owner controlled insurance program, then the contractor doesn't have to include the workers' compensation. The other thing I want to say about workers' comp is that this is just an estimated rate. It could be different for each contractor. It could be different on each project. So pay attention and look at the area, the locality where you are working, and then get the right amount for that particular trade. So let's go back to the whiteboard. Okay, so that is the labor rate and how we get the labor rate. On the equipment rate, there are a couple of places where you can get a very good equipment rate. In California, I think the Caltrans gives us every year they issue the equipment rates, and that's what we use for those equipment. Where else can we get it? I think there is what we call the Blue Book, equipment Blue Book, have list of equipment rates. At the federal level, there are also some federal places you could look for the equipment rate. I think I'll put some of the references below so you can take a look at those. So now we've talked about the construction costs. We've talked about the direct costs. We've seen how to calculate the direct costs. It's of course based on the labor costs, based on the equipment costs, and based on the material costs, and then the subcontractors costs. Now, can we expand on the general conditions? I've already explained that the general conditions, of course, are the costs for temporary offices and supervision on the project. The G&A cost is the office overhead. The bonds and insurance are there to protect the owner against contractors' failure. And then the next thing I'm going to talk about is the contingencies and escalation. Now, you have to understand that cost estimating is a forward-looking endeavor, meaning it's like a forecast. We look at the information you give us, and then we look at the market conditions, and then we predict what the cost of the project is going to be. You should understand that prediction and what happens normally are not always the same. Okay, and in construction estimating, we tend to follow certain stages as design progresses. So in the construction industry, design progresses through stages. When the owner gets an idea, or the owner gets an idea, he talks to a design firm. The firm then comes up with a concept design. So we go through the three basic or the three common stages that design goes through are the conceptual. Let me put them here. Oops. We have the conceptual design. And then we have the design development. And then we do have the construction document. So these are the stages that, and then after that, then we have the construction what we call the construction phase. Okay. Now, the design phase, the design phase is obviously called the pre-construction stage. The pre-construction stage. So, if you want to break this into two, we have the the pre-construction phase, of course, and the construction phase. Now, during the pre-construction phase, design goes through conceptual design, design development, and construction document. Now, the conceptual design occurs very early in the planning stages. Okay, and so the information that we get are not really sometimes representative of the entire scope of the project. We may have very scanty information on the project, and then we may have to predict the cost of what the cost of the project is going to be in, let's say, maybe 2 years when they build the project. Now, because this is a prediction, most of it than not, there's always a cost difference between what the actual cost is versus the predictions that we do. Okay, and and because it's a prediction, okay, there's always some level of uncertainties on the cost estimate that we give owners, and that level of uncertainty is higher at the beginning of the project, because at the beginning the estimator or the estimating firm or even the architect have very little information on the scope of the project. Okay. And and as design progresses, that uncertainty reduces, because we do get more information. The project becomes more refined, okay, and therefore the variability or the uncertainty in the cost estimate reduces. And so we approach the actual cost. So if I'm putting this on the board, it's something like this. Forgive me for my drawing here. So it's going to be something like that. Yeah. So if these are the design stages, let's say this phase is the conceptual, you're going to have something like this. Okay, and this is the level of what do you call it, the value of uncertainty. At the early stages, that uncertainty is very high, and then as you approach the final construction or the construction document drawing, that uncertainty reduces. Now, so how do we take care of uncertainties in construction project? And that's where contingencies comes in. So contingencies are put in place to take care of the uncertainties in the cost. I hope I'm making myself, I hope you understand what I'm trying to say here, because we know that there are uncertainties in the estimate. Okay, the prediction that we are giving the owner might not be the true cost of the project from what we know. And from the information that has given to us, we know certain things are going to change. And because of that, we put in there contingencies to really deal with that uncertainty. So that is the use of contingencies. I want to move this somewhere. I don't even know where to put this. Let me take it out. But just for an explanation, I can have more space to write. Okay, so that is how we use contingencies. We put contingencies in there to deal with the uncertainties in the estimate. Now, you also have to understand that contingencies, or determining the level of contingencies to carry, could be a big thing, okay? And so sometimes some agencies would actually do what we call a risk management to help them figure out or help them determine the appropriate contingencies to carry on the project. Because I've been on a few projects where we have to do quantitative risk analysis in order to come up with the appropriate contingency to carry on the project. But for most projects that we have engaged in, it's all based on experience. It's also based on the data that we have, and so we would say at this level of design, from our experience, this is the contingency amount that we carry. Now, I wish I could give you concrete numbers on what to carry or what to look for at every stage of design. Um, I'll give you something, but let me explain. Let me still talk about contingencies in construction. In construction, we normally have two contingencies that we always. Sometimes we include one in the estimate. Other times we don't. There are what we call. Let me put it here. So I'm gonna put here and put here contingencies. So we do have what we call the design contingency. And of course, the construction contingency. Now, like the name suggests, design contingencies are included in the estimate to really take care of design progressions. Okay, like earlier I said that design goes through stages from the concept to the design development. Now, what normally happens is that at the concept level, the design maturity is maybe about 15 to 30%. So there are a lot of things that are not that have not been developed yet. And so as the design progresses, they add more information. They add more information in the design. They add more information in the project specification. And so we put in the design contingency to really take care of the design progression. Now, there's always the argument that because if we have a design contingency in there, can we really change the scope of the project, or can we add something to the project? And the answer is no, because the contingency that we put in there is for a well-defined scope. Okay, so for instance, if an owner comes during the planning stages and said they want a 600-bed hospital, and we put up let's say a conceptual estimate for the 600-bed hospital, and then we put in additional 35% for, or 25% say for the design contingency, and owner sees the 25% and said, okay, because the design is not complete, I can change my mind, I can move it to 800-bed, and that should be covered as part of the contingency. That is not how it works. Okay, now if you add 200-bed to a 600-bed hospital, that is a scope change, and that would of course require additional costs beyond the escalation that we do have in there. Now, the construction contingency is what we put in there for changes that we think might happen during the construction stages of the project. Okay. Other times you're going to see people describe their contingencies different. So if you are working for let's say an FTA project, and you are doing something like what they use, you look at what they do have something, they do have their own template, and they call it the standard cost category template. And in that template, they describe their contingencies different from the design contingency and the construction contingency. So for them, they have what we call the allocated and unallocated contingencies. The allocated contingencies look at conditions, look at contingencies specific to each of the categories that they have, and then the unallocated deals with the general conditions for the entire project. But most often than not, you are going to have the design contingencies, of course, and the construction contingency. Now, what else do we talk about? We've talked about, let's talk about the market effects on the construction costs. Yeah, but I also have to mention that during the construction phase of a project, we don't we don't normally include contingencies in the contractor's estimate because if you think about it, change orders are for change orders we try to um, get the actual cost without contingencies because change orders are supposed to be very detailed. We should have all the information on the job. We should have all the necessary documentation to really calculate the cost of that change order using without using contingencies. A few times where you might use contingencies are if you do have a change order that looks into the future, then you might think about adding some contingencies and then some escalation. Now, talking about escalation, what is escalation and why do we include escalation? Let me explain that. Now, remember earlier I said that the Department of Industrial Relations in California changes the labor rate every 2 years, and most often than not, the price goes up. Okay. The construction happens in the market where material prices and prices generally goes up. Okay, there's always some market movement. And so when we are putting up an estimate, we have to find a way to deal with that market movement or the changes in price or the increase in price. So if you are supposed to build a project 5 years from today and I give you an estimate today, then in 5 years, that estimate might not work, right? There's something called time value of money. Okay. Now, what time value of money means that $1 in your hand today is not going to be the same as $1 tomorrow or $1 2 years from now. In 2 years from now, that dollar might be 50 cents. Oh, sorry, I think this is just a stream. Let's say in 10 years, that dollar might be 85 cents. Okay. And so if I'm predicting the cost of a project 5 years from now, I have to find a way to take care of the market changes, the pricing changes that could happen within the market. And this is even outside the project. This is a market that determines these things. And this is where we use cost escalation in our estimates. Okay. So you could see that if all things being equal at the concept stage, I should have more escalation than at the construction document phase, because the conceptual estimate occurs very early in the project life. Okay, so let's say if the owner wants to build the project 5 years from now, then I have to find a way to deal with 5 years worth of escalation. And at the concept level, let's say at the construction document, the whole design progress takes a year. Then at the construction stages, I have to reduce that escalation to 4 years from the date of the construction. Okay, so let's talk about escalation and see how it works. Now, I have seen two methods of calculating escalation. Okay, the common one is we normally calculate escalation from the date of the estimate to the midpoint of construction. Now, the other one is, and I think this is with the FTA or what we call the SCC, the standard cost category template. They calculate estimate the escalation based off on what we call would I say cash flow or the project schedule. So they look at what you're going to complete each year, and based on that they calculate the escalation. And I think I've done a comparison estimate before. I look at calculating the estimate from the date of the estimate to the midpoint of construction, and then I also look at it from, of course, the projected cash flows that the contractor is going to perform. It turned out that when I used the cash flow, I got a lower escalation number. But again, that of course depends on how the contractor end value is going to be, okay? Or the planned value, sorry. The planned value is distributed. If the contractor is doing more at the early stages of the project than at the later stages, then of course the escalation will be lower than if he's doing more at the end of the project. Just because if you are doing more at the end of the project, you're going to have more of the amount being escalated through a couple of years or more years than if you're doing more at the beginning. So to calculate escalation using the midpoint, you need would I say three things? You need the cost, you need the escalation rate, and you also need the project timeline. Okay, so if I come here, if I come here and put in here escalation, I'm going to have, of course, it needs the construction amount that you've calculated. You also need the escalation rate, and then of course you need the project timeline, beginning and then the duration. So you need the beginning of the beginning. Beginning and the duration. I'm looking for end and duration. So to calculate escalation, these are what you need. You need a construction amount, the escalation rate, of course, and the beginning and duration. So if we are doing the midpoint, would I say midpoint theorem, or we're doing the midpoint, we're using the midpoint to calculate escalation. Then if we look at a project that starts in 5 years with 2 years worth of construction duration, then the escalation period becomes 6 years. And how do I get 6 years? Okay, so if we do the estimate today, we are saying that we will be saying that the estimate project start time is 5 years. Okay. And the project duration is 2 years. Remember, we are calculating. Let me push this somewhere. Can I squeeze it? Let me move this so I can get more space, and then we can have more on the whiteboard. Yep. Okay, so the project start time is 5 years from now. While I'm doing the estimate, the project duration is 2 years. Remember, we are doing midpoint of construction. So if you divide this by 2, you have 1 year. If you add to the 5 years, you have 6 years worth of escalation. I'm trying to avoid doing any calculations here. I'm just introducing the concept because of time. Okay, so that's how we get the we get escalation. What else do we have to cover? We are way into the 1 hour mark, but I want to end here. But before I do that, I think I do have the cost breakdown structure here. So let's briefly talk about the cost breakdown structure, or work breakdown structure for or work breakdown structure. Now, what is the cost breakdown structure? The you see, construction cost is made up of so many activities. Okay, and the industry has to find a way to break down the cost for, can I say, universal acceptance. So anybody can universal acceptance and being able to communicate about the cost of a project. We can't have a conversation if everybody has their, or if everybody have their own way of doing the estimate. And so that's where work breakdown structure or cost breakdown structure becomes very useful. Now, elsewhere in the world, I was trained as a quantity surveyor, and in quantity surveying, the document that we used was the SMM, which is the SMM. And back then, I think we were on SMM 7, meaning the SMM has gone through like a 7th edition. And that was what we were using to group our estimate. And so anybody who uses SMM, when it takes my my quantity survey or my bills of quantities, would be able to understand, because I've really arranged it based on the on a standard, which is the SMM. Now in the US, we use two main cost breakdown structures, and one of them is called the master format, okay, and the other one is the unit format. The master format, so let me write them here. We have two. I think there's somebody there making so much noise behind. I apologize if it's getting into this video. So we do have two things here. We do have the master format and the unit format. There's something wrong here. Oh, that's right. I see that here. Master format. It's fine. Master format. Is it double T? Master format and the unit format. Is it double T? Sorry guys, I think it's one T. What is wrong with that thing there? Okay, I think it just doesn't understand master format. So we do have the master format and the unit format. What a master format does is it breaks down the cost according to the trades. Okay, so when I say according to the trades, so we do have concrete tradesmen, we do have masonry, we do have structural steel, we do have partition walls, we also do have electrical, mechanical. Now these are trades, and so what the master format does is it breaks down the cost according to these trades. The unit format is different. The unit format actually breaks down the cost according to the elements in the building. Okay, so it will talk about, instead of talking about concrete, it will talk about the superstructure, the substructure, okay, the substructure and the superstructure, and then it will go further and talk about the foundation, and then we'll talk about the shell, and then we'll talk about interior partition or interior construction. Of course, the shell is everything else that covers the building, so you're looking at the exterior construction and the roofing as well. Okay, and then we'll talk about interior construction, so that everything that we would do inside the shell becomes interior construction. And then they may have further break down the interior construction into partition, into finishes. So it takes and breaks down the cost according to the elements in the building. So let's take a look at them. I know I do have one. So let's take out the master format here. So this is the master format breakdown. Division 1 and 2 actually deals with remember we talked about general conditions and requirement. That's where the contractor gets most of the cost for the general requirements, and then they add on their supervision on them. And then division 2 deals with existing conditions. Now, when they say existing conditions, they are normally dealing with conditions that exist on the project that you have to deal with, and it's mostly demolitions. Okay, so division 2, if you look at division 2, let's go back to see the division 2, existing conditions, and mostly for projects it's more on the escalation side. Division 3 talks about concrete. Division 4, let's see division 3, concrete. Division 4 talk about the masonry. The masonry, they do have categories, but if it's something you are interested, you can look at the subcategories. When we are doing a big estimate or a large project, we try to break down into categories as much as we can. Okay. Now the uniformat, is actually also used globally. I've seen it's used globally. So let's take a look at the uniformat. So you can see that the uniformat 2 elemental classification for building specifications, cost estimating, and analysis. If you really take a look at it, we do have the substructure, the shell, the interiors, the services, equipment and furnishing, special construction. And then you go to level 2, which further breaks it down into foundations, basement construction. Let me get some water. And then we have the superstructure. This is where we do the floor constructions and the roof construction. Okay, so those are the two main cost breakdown structures that is predominantly used in the US. Now, what are the advantages of using one over the other? Well, what I would say is this. At the early stages of a project, the uniformat is very, very, very important, useful during the early stages of a project, just because it deals with the elements. One of the things that you are going to see in construction cost estimate is the cost of over design, and so during those stages, during the early planning stages, if an architect over design a project, let's say the owner's budget is 100 million, the design cost comes in 110 million, we have to find a way to, if the owner can get the additional 10 million, then we have to find a way to get the project within the 100 million. Okay. And through a process called value engineering. Okay. And it's easier to really pinpoint the areas where the cost overhead, where there's more cost, and where an owner or the architect team can focus on to reduce the cost. So, for instance, we can say the exterior skin is coming in at maybe 50 million, and we feel that exterior skin is expensive for this project. The owner can just make changes to the exterior skin, and then the estimator can re-estimate that particular element to see if we can get within cost. Now, it's difficult to if you are using the master format, because the exterior skin will be broken down into very many parts into the estimate if you are using the master format, and therefore you have to be looking at different trades to see the effect of that change on the cost. That's why the elemental breakdown is very good at the early stages in the project. Now the master format becomes also very useful. Most projects that are based off on the trade at the trade level, specifications are also written at the trade level, and so when they bid the jobs are always bid at the trade level. So you have the concrete, the masonry, the electrical, all are based on trade. And so if you do have an estimate at that level, it's easier to make comparison. Okay, it's also easier to manage the project, using the master format estimate. It's just because on the construction side we are dealing with with trades and not elements. So these are the major differences that I can say about the uniformat and the master format. Now I think that brings us to the end of what we I want to talk to you about today. I think I do have the general conditions sheet, general conditions template. Let me see what I can find it. Oh, I think this one. So this is a list of the general conditions. You have the project management, the bonds and insurance, but sometimes we take the bonds and insurance and we add it somewhere else in the estimate. Then you have your site conditions. If you need this list, just email me and I'll send you a copy of this one. So that comes to the end of what it is that I want to cover today. These are just concepts to help project managers. This is not to make you an estimator. Like I said, to become an estimator requires a lot more than understanding these concepts. Okay, you need to be able to read construction drawings. You need to also understand the construction process and methods, because there are certain things that might not be on the drawings, but as an estimator, or if you understand construction methods, you know you have to include that in the estimate. So that is that. Let me leave my contact here. So if you, in case you need to talk to me, you can always reach out to me. You can always reach out. My email address is sdanquah at danquahgroup.com. I'm going to push it here so you can see it better. So sdanquah at danquahgroup.com. I'm trying to move it here. So, okay. If you have any estimating question or you're looking for help on your project, whether it's a change order or whether it's a new project that you are building, you can always reach out to me. And if I can help you out, I know some estimating firms who are really, really good at this, and they can, of course, assist you with your project. Again, so thank you all for listening to this. If you really want to reach me, if you need any support, let me delete this before I go. Now, if you need support, you can always reach me at sdanquah at danquahgroup.com. Thank you once again for listening to this tutorial. I think there'll be more coming. The goal is to really help contractors and project managers deliver their projects. So there'll be more of these coming in the coming days and months. So thank you all for listening to this.